So uh, the aim of surveying is to make plans and maps to show various objects on the ground at their relative position to suitable scale. Various steps involved in making the plans is explained in the chapter. Countering is a technique of showing the levels of ground in a plan. This technique is also explained in the article. After completing field work in chain survey and compass survey, lot of office work is involved to prepare the plan of the area surveyed. In plan table survey, office work is less. However, plan table survey is kind of ancient work. It's nowadays we just use digital equipment, and plan table survey is very rare example. The office work involved consists of applying necessary correction to measurements, drawing index plan, selecting scale, selecting orientation, drawing network of survey lines, distributing closing error, filling in details, coloring the map, drawing graphical scale, and writing index. Applying necessary correction to measurements. Necessary tape and chain corrections and correction for local attraction in case of compass survey should be applied to survey lines measured. On a roof sheet, index plan, also known as K plan, is drawn. Its need not be to the scale, but distances and directions of network of survey lines should be approximately to a scale. This plan is necessary to identify the shape of the area to be plotted. This index plan in Ukrainian form or in Russian form, the equal terms for this index plan are abris or kraki. I will show you this abris. Sorry, just doesn't work. Here you can see abris is of German word abris. Uh, it's kind of sketch of the future work. I will show you. Example of abrises. No, let's try to see the examples. Yes, something like this. It's let's try to English index plan. Show you in civil engineering. Yes. This index plan schematically show the main features on the ground, the control network, the main buildings, fences, rivers, forest, wood, meadows, etc. Selecting scale. Depending upon the type of survey, scale should be selected. In general, scale selected should be as large as possible, if a range of scale is recommended. It depends upon the size of the paper as well as largest linear measurement in the field. Traditionally, we have fixed list of scale for topographic maps. However, or topographic plans. However, in civil engineering, while making the plan of civil engineering object, civil engineering construction territory, we can use different scales. The better idea is to use scales kind of 1 to 50, 1 to 100, 1 to 200, etc. Selecting orientation. Looking at the plan index, orientation of map is to be decided so that the map is placed in the middle of the drawing sheet with its larger dimension approximately along the length of paper. North direction is selected and marked. Drawing network of survey lines. Studying index map and orientation of paper. First station point of survey is marked. Starting from here, one by one, survey line is drawn to the scale in its direction. After drawing all survey lines, it is clearly seen whether the selected scale and orientation are appropriate. If necessary, they may be changed and network of survey lines redrawn. Distributing closing error. If we have a compass survey, the distribution of closing error should be made graphically on the plan. However, we just distribute all the corrections in Microsoft Excel. So finally, we have final coordinates, corrected coordinates, and we just can put this, draw the position of points by their coordinates. Filling in the details. Surveyor has to go through details of one by one survey lines. One by one point of object noted in the field is marked on the drawing sheet by converting the change and offsets to the scale. Main scale and offset scales will be quite useful for this work. After making the salient points of the objects like building, boundary lines, roads, culvert ends, trees, electric poles, etc. The respective lines are joined to the mark the objects. The field book will be useful in identifying the objects. If the object is building, the measurement may be only for a salient point near the survey lines, looking at overall dimensions of the building, and scaling down complete building may be shown in the plan. Thus, attending to the field observations of each survey lines, all details may be shown. Standard conventions should be used in the showing the objects. Contouring the map. If colored maps are to be made, the recommended light washes of standard shades as listed in international standard. Drawing graphical scale. As a drawing sheet may shrink and measurement, the measurement taken from a shrunk sheet may mislead the distances between any two objects on the map. It is necessary to draw a graphical scale of 150 to 270 millimeter long, just over the space for indexing the drawing, which is right hand side lower corner of the sheet. And write an index. Index is details giving the description of the area plotted, scale used, name of leader or survey party, and the person drawing the plan, map, etc. It is normally written in the right hand side lower corner of the drawing sheet. North direction is shown neatly at the right hand side top corner. What does it mean, contours? A contour line is imaginary line which connects points of equal elevation. Such lines are drawn on the plan of an area after establishing reduced levels of several points in the area. The contour lines in an area are drawn keeping difference in elevation of between two consecutive lines constant. For example, in the figure 17.1 shows contours in an area with contour interval of 1 meter. On contour lines, the level of lines is also written. Characteristics of contours. The contour have the following characteristics. Contour line must close, not necessarily in the limits of the plan. The second, widely spaced contour indicates flat surface. Closely spaced contour indicates steep ground. Equally spaced contour indicates uniform slope. Irregular contours indicate uneven surface. Approximately concentric closed contours with decreasing values toward center, as in the figure 17.1 here, means the indicate a pond. So the elevation in the middle is 95, 96, 97, up to 100 meters above sea level. Mainly we use elevation above sea level. Approximately concentric closed contours with increasing values towards center indicate hill. Contour lines with U shape with convexity towards lower ground indicate a ridge line 199 meters, etc. Contour lines with V-shaped with convexity towards higher ground indicate valley. Contour lines generally don't meet or intersect each other. If contour lines are meeting in some portion, it shows existence of a vertical cliff. You can see these contour lines. It's mistake because contour lines must not have any gaps. Where vertical cliff is situated, we just often need to use another cartographic sign. If contour lines cross each other, it shows existence of overhanging cliffs or cave. However, it's not very and it's not common situation of cliffs and caves. How should we use of contour maps? Contour maps are extremely useful for various engineering works. A civil engineer studies the contours and finds out the more nature of the ground to identify suitable site for the project works to be taken up. By drawing this section in the plan, it is possible to find out profile of the ground along the line. It helps to find out depths of cutting and filling. If formation level of road railway is decided. Intervisibility of any two points can be found by drawing profile of the ground along the line. The roads of the railway road, canal or sewer lines can be decided so as to minimize and balance earthworks or solid works. Catchment area and hence quantity of water flow at any point of Nala or river can be found. This study is very important in locating bands, dams, and also to find out flood levels. From the contours, it is possible to determine the capacity of a reservoir. Methods of contouring. Contouring needs the determination of elevation of various points on the ground and at the same, the horizontal positions of those points should be fixed. To exercise vertical contour leveling work is carried out and simultaneously to exercise horizontal contour chain survey or compass survey or plantable survey is to be carried out. If the satellite is used, both horizontal and vertical controls can be achieved from the same instrument. Based on the instruments used, one can classify the contouring in different groups. However, broadly speaking, there are two methods of surveying, direct method and indirect method. Direct method consists in finding vertical and horizontal contours of the points which lie on the selected contour line. For vertical contour leveling instrument is commonly used. A level is set on a commanding position in the area after taking fly levels from the nearby benchmark. The plan of collimation height of instrument is found and the required staff reading for a contour line is calculated. Indirect method. In this method, levels are taken at some selected points and their levels are reduced. Thus, in the method, horizontal control is established first and then the levels of those points found. After locating the points on the plan, reduced levels are marked and contour lines are interpolated between the selected points. For selecting points, any one of the following methods may be used. Method of squares, method of cross sections, or radial line method. Method of squares. This method is very common in civil engineering because you probably know that uh, civil engineers make so-called engineering grid, and every corner or cross of the line of the grid, the coordinates of this it's very easy to calculate. However, we should take uh, we should get the elevations of every corner. In this figure, you can see numbers from 1 to 6. It's a number of lines, of rows, and A, B, C, D, E, F, G, it's a number of columns. So every point can be marked as A1, A2, B1, B2, B5, B6, etc. Uh, for so we just need only uh, position, plane position of every point and the elevation of the point. Then we can uh, draw the contour lines manually or use different software. The size of the commonly used size of square varies from 5 to 5, 5 by 5 meters or to 20 to 20 meters. Levels of all grid points are established by leveling. Then grid square is plotted on the drawing sheet. Reduced levels of grid points marked at contour lines are drawn by interpolation. Well, I want you to answer my question. Does anybody know what does it mean interpolation?
Does anybody know what?
Interpolation. What does it mean? You can type down your answers, or you can also try to explain it orally. You're welcome, please. If nobody knows, yes, of course, you can use Google to find the answer, да? Sure, it's determining a value from the existing values on a given data set. For example, interpolation means finding of function here. The easiest example of interpolation is linear interpolation. If you have argument 0 and argument 1, we also know the function values in these points. Um, if we know that the function is a linear function, we can find the value of the function in the middle. Here you can see the explanation of the linear interpolation. Uh, well, I would like to show you example of work for my students. Well, the explanation of linear, of how to make contour lines in Ukrainian, you can find on my YouTube channel. And now I will show you how it is possible to make the contour lines manually. In any case, all the methods of cross-section or methods of radial lines, it's just method of point distribution. In any case, the interpolation should be done in the same way. Election geodesy. Here you can see an example of just part of territory it was very long time ago. It was our practical works. Interpolation, relief and interpolation. This video is just advertising. Well, so home assignment for the next time should consist of just edit. So the subject will be contour lines. The assignment will be with I will finish the assignment just later, but now I will take this example and will show you how does it work. You can do all this necessary work for example in PowerPoint software or something like this. Here you can see different variants. We have only 4 students, so and 25, not 4, but let it be different variants, for example 10 variants.
You didn't show screen.
How many students are in your class? 6?
6. But you don't show screen.
6 students. So here you can see the necessary data for your work.
We can't see screen.
Cannot see screen?
Yes.
Sorry. No. Contour lines. Here different number of points. Point 1, point 2. And it's a variant for different students. 1, 2, 3, 4, 5, 6. Well, and now we should, for example, we just need to have the elevations for 25 points. We put this elevation near and just can uh, use the marker we just use the value of elevation. We just need to write down these values near every point. 27, 20, 28.6, point number 3, 31, point number 4, 32.8, 35.1, number 6, 36, number, sorry, point 3, point 7 is 37.2. Point 8, 34.9. Eight, 10, 35.3. Then we should continue this work. 11, 32, number, point 8, and 12, 35.3. First of all, we should find the highest and the lowest points in the list. And then the lowest point is 27 meters above sea level. The highest is 45 above sea level. The difference between these are 27, 37, 10 meters, and 18 meters. So we just need to find the position of contour line, each contour line that should appear between points 1 and 2, 2 and 12, 2 and 7, 2 and 3, 2 and 11. So we make a kind of grid between all these points and should calculate proportion of position of every contour line that should occur in this position. Let's begin from the line between its imagine line between 27 and 28.6 meters. It means that we have height difference or elevation difference of 1.6 meter. It is possible to divide the distance between point 1 and 2 onto 16 parts. Well, the 10 parts, and when we just, we can imagine our motion between these points. For example, we are stand on the point 1 on the elevation 27 meters and go up the hill to the elevation 28.6. And while we are working of 10 parts, it will be the mark of 28 meters. And then, this mark will be closer to 28.6 than to 27. We have 18.6 meters difference, and so it will be the position of our future counterline. Next step, we go between point 28.6 to 32.8. We have 29, 30, 31, and 32. 1, 2, 3, 4 contour lines. 28, 30, 31, and 32. The same way we should find the difference between 28 and 37. It will be 10 contour lines, yeah? Or 9. 28, 30, 31. It's not easy to work with let's move on. Let's use another color. So the line 29, the line 30, contour line 31, and 32. Well, all these contour lines are between the points 2 and 7, and all this also we need to find the number of contour lines between point 11 and 12. It will be 33 line, 34, 35, 6, 7, 8, 9, 40, 41, 42, 43, 44, 45. So in this case we just draw all these contour lines. So 32 is in between 2 and 7, because we have 28 and 37. 32 line, 33, 35, 36, and 37. 37 line should go in this way, and 36, 35, 34, 33. And the 32 line will be in between here, 32, 33, 4, 5, 6, and 7. Here you can see 7, 6, and 5. 5 is very closely to 34.9. And between 34.9 and 41 is 35 line should something like this. Also, we should find the line 32 in between 3 and 4 points, and all this we can use. And then continue. And 32, 33, 34. In the middle between this. So finally, you can make the picture of relief all this of this area. Well, another option of contour lines creation another option of creation of contour lines is different software. It can be GIS software, it can be AutoCAD software, etc. One of the easiest way to create contour lines is Surfer software. Does not work. Surfer, one of the best programs and easiest programs to create digital contour lines, and you can see example how does it works. Here you can see contour lines drawn automatically by the software. Here you can see different examples in Russian form, etc., etc. The one option is to make contour lines manually, or draw contour lines manually, and on the next step try to draw these contour lines we using different software. Try to draw these contour lines using, for example, Surfer software. However, we need to make the make kind of special data file for automatically creating contour lines. It is possible to download free trial version, so it's free of charge for students for non-commercial work. You can try, and if you like, you can buy it. You need no credit card to just download the version of the program. You just need to type down earth science or construction. For education purpose. If it's possible to download this software, you just need to create grid file. Then it's possible to follow the link and download the software on your laptop. You can find a huge amount of different examples of contour line drawing manually and using different software on YouTube platform. Also, it is possible to contact me via Telegram. My Telegram if necessary, contact me via Telegram. It's my nickname on Telegram, UAGEO. Well, let it be 10 points. The easy option is to print this piece of paper and just write down the elevations near every point. You can use a pen for elevations, and then you can use the pencil for drawing contour lines, because it will be easier. File. Well, and I give you assignment to try to work with contour lines. Here you can see a huge amount of video that explain how to draw elevation contour lines manually. You can see really good examples with more than 100,000 views, and here you can see explanation of how this contour lines can be drawn on graticle. So all these video are useful, and here you can see example of how these contour lines drawing on the part of topographic map. Well, does anybody has any questions? Hello?
No.
Well, I am sorry because so I just